Okay, so now we're into chapter 9. Chapter 9 talks about transport technologies. Got a couple of transport technologies that going to discuss from your text. So we've now discussed the premises environment and a variety of wired and wireless technologies. Remember, access refers to the collection of technologies that give the user, whether human or mechanized, the ability to access the transport domain of the network and gain access, in turn, to the content they seek. Next, we're going to look at transport and explore it. Because businesses are rarely housed in a single building, and because customers are typically scattered across a broad geographical area, particularly multinational customers, there's a growing need for high-speed, reliable, wide-area transport. Wide area, though, can take on a variety of meanings. A company with multiple offices scattered across metropolitan expanse of a large city requires inter-office connectivity to do business properly. On the other hand, a large multinational with offices and clients in Madrid, San Francisco, Hamburg, and Singapore requires connectivity to ensure that the offices can exchange information on a 24-hour basis. These requirements are satisfied through the proper deployment of wide area transport technologies. These can be as simple as a dedicated private line circuit or as complex as a virtual installation that relies on asynchronous transfer mode, ATM, which your text talks about at some length, or an internet protocol for high quality transport. Dedicated facilities are excellent solutions because they are, well, dedicated. They provide fixed bandwidth that never varies and guarantees the quality of the transmission service. Because they're dedicated, however, they suffer from two advantages. First, they are expensive and only cost-effective when highly utilized. The practicing model for dedicated circuits include two components. First, the mileage of the circuit and the bandwidth. The longer the circuit and the faster it is, the more it costs. The second, because they are not switched and are often not redundant because of cost, dedicated facilities pose the potential threat of prolonged service outage should they fail. Nevertheless, dedicated circuits are popular for certain applications and widely deployed. They often include such conditions and solutions as T1, which offers 1.544 megabytes per second of bandwidth, DS3, which offers 44.736 megabytes per second of bandwidth, and SONET or SDH, which offers wide range bandwidth from 51.84 megabits to as much as 40 gigabits. The alternative to a dedicated facility is a switched service such as frame relay, asynchronous transfer mode, ATM, or in some cases, gigabit Ethernet, not to mention the various services that IP and multi-protocol label switching, MPLS, offer. These technologies provide virtual circuits. Instead of dedicating physical facilities, they dedicate logical time slots to each customer, who are then able to share access to physical network resources. In the case of frame relay, the service can provide bandwidth as high as a DS3, thus providing a replacement technology for lower speed dedicated circuits. ATM, asynchronous transfer mode, on the other hand, operates hand in glove with SONET, a gigabit Ethernet, when deployed in a switched configuration, offer speeds of 1 gig or higher. Finally, optical networking is carving out a large niche for itself as a bandwidth-rich solution with good quality of service, QoS. Your text begins with the discussion of a private line called point-to-point. So if you take a look at your text and start looking through Chapter 9, you'll see that the text starts off on page 369 talking about frame relay and then moves quickly into from frame relay to ATM. So there's a very good explanation in here of asynchronous transfer mode. Asynchronous transfer mode, again, is one of those protocols that was forever stuck in the standards, in the regulators, trying to decide what asynchronous transfer mode, ATM, was going to look like. And before gigabit, it was the Cadillac of protocols in getting switched packets about the internet. So take a look at ATM. If you're not familiar with it, your text gives you a very good explanation of ATM. Starting on page 386, the text starts talking about optical networking, which really goes hand in hand with an ATM protocol network. It talks about optical networking, a little bit about the sources, the light-emitting diodes, and laser diodes, and then talks a little bit about the origins of fiber optic and fiber optic cables. If you haven't taken a fiber optic course, it's a very interesting to study and looking at the evolution and what's available today. When I used to work at the test site back in the day of underground nuclear testing back in the 90s, we ran miles and miles of different types of fiber optic cabling because we needed to get the test data transmitted from miles away from the test center back to the data recording devices. So your text goes into looking at the makeup of a fiber system, a fiber network, talks about optical switching and routing, and then it looks at some of the other applications and benefits of fiber. So this concludes long-winded coverage of transport solutions. Clearly, they are remarkably diverse, but with that diversity and complexity comes an equally far-ranging degree of capability. So in the next section, we'll look at in Chapter 10, the IP takeover.